Word problem number 5 is what I've been trying to key you up for in the last two, which are really kind of algebra questions, but we've been using P of t equals PERT. You can call it P naught for the starting population if you like. And the reason that I've been keying you up for that is they give you something like this now, where they say, let's see if T be the concentration of a drug. And that should immediately tell you, we're going to be using exponential growth or decay. And you're going to want to have this formula on hand in your brain. As the body eliminates a drug, the function decreases at a rate that's proportional to the amount of the drug present at the time. So that means if you have like 100 of a drug in you, it's going to eliminate faster than if you have 50 in you, and so forth. So if you have more, it eliminates faster. If you have less, it eliminates slower. That's exponential decaying to a t. And then they give you some confusing stuff. They say, thus, the derivative of the function is equal to some constant times the function, where k is a positive number. And they say that because they write minus k there, called the elimination constant of the drug. So let's just wait a second before we solve this. What does that even mean? It means that the derivative is basically a number times the original function. And that's what e to the x does. Is if I have e to the x, y prime is going to be e to the x. So they're saying y prime equals y here. See how they're the same? Now, if I do it a little bit different, if I back it up, calculus student, and I say y equals e to the ax, well, y prime is still e to the ax, but it's times the chain rule where you have to bring the a out. And that's what this says here. The derivative is equal to a times the y function itself. That's what this says. So all that baloney is telling you to use something like this, the exponential growth function. That's all that it says. That's what that ugly math says. But now they're going to give us something specific, so let's look at it. Okay, if the concentration begins, that's what C naught is, it's the starting concentration, starts at time 0, find the concentration at time t. So you would literally just write it as a C of t instead, like this. That's what they've asked you for. That's part A right there. That's the formula. That's the question. It's just hard to understand based on how they write it. Now we get an actual problem. They say if the body eliminates half the drug in 30 hours, how long does it take to eliminate 90% of the drug? So we'll write 1/2 equals 1 for our starting amount, 100% versus 1/2, e to the 30r. And then we'll take the natural log of both sides like this. And we get ln of 1/2 equals ln of e to the 30r. Now that allows us to take the exponent out, and that's why we do it. So we'll write it as ln of 1/2 equals 30r ln of e. And now ln of e, that's equal to 1, so that's just gone. We'll divide the 30 out here, and we're going to get the rate of decay. And I got about negative 0.0231. That should be more than enough for our purposes. And now we can come to finish up part B, and they say, how long does it take to eliminate 90% of the drug? So that means the remaining amount will be 10%, so we'll say 0.1 equals 1 e to the negative 0.0231 t. Well, there's a variable up here. That's a natural log to solve for, so we'll take the natural log of everything and bring that back out again. Should be getting good at this now. This is the last one we're going to do in this review. So that'd be negative 0.0231 t ln of e, which crosses out because the natural log of e is equal to freaking 1. Okay, now we just need the natural log of 0.1. We're going to divide by this tiny little number. 0.0231. And I'm going to get t is equal to 99.68 years. It's a long time to eliminate a drug from the bloodstream. So half the drug's eliminated in, hours, sorry, 99 hours. Half the drug's eliminated in 30 hours. But you still have 10% remaining after 3 days. And this is exactly why marijuana users can have that drug show up 6 months after their last use even. If they were a heavy user and they built it up in their body fat, it can take forever to remove. So make sure that you understand this, because when you get into differential equations and further calculus, you need to be able to see that this is y prime comes from its original function with only a constant multiplied. That is e to the x here. So I hope that's cemented for this differentiation review, because we're not looking back.